with Nomenclature 3, I've recommended 2 EP tasks about naming carboxylic acids and naming amines. Those are the 2 homologous series whose functional groups we're going to learn about today. I forgot to edit it with the SciPad stuff I recommend you do. I'll edit that in later today. Basically, as I said last week, you have the choice, the option to do either the SciPad work that I recommend or the EP work that you recommend. You don't need to do both, okay? You choose which one works for you. If you like to do the stuff on EP, and that's fine, that's cool. But if you prefer a workbook, then SciPad's the way to go. Just do one or two. Don't do one of the 2, not both, because that's just draining. Because you don't need that much practice to get it. I feel like after about 15, 20 minutes of practice, we know how to name all of these homologous series. So don't bang your head against the desk and spend like 3 hours each night trying to do all the work.
But
so
if you enjoy that type of thing, feel free to, right?
Yeah, feel free to if you want to. Cool. So let's get into it. We know that there are a variety of ways to represent an organic molecule. And I keep showing these depictions to keep in your mind that all of these ways are equivalent. They all represent the same structure. So I have the molecular formula, the structural formula, and the condensed structural formula, all which are different ways of representing possibly the same molecule. I prefer the condensed structural formula, and that's because, as I explained last week, it saves time. When drawing large molecules, you don't have to draw every single line or bond between all the carbons and hydrogens. That gets really time-consuming and mundane. Cool. So we know that at level 2, there are 7 functional groups we are learning about. We've learned about the first 5, and in bold, you can see the ones we're learning today. We're learning how to name amines and carboxylic acids. So let's get into it. By the end of today, you should be able to draw and name them, and draw them in a variety of different ways. Like, for example, a condensed structural formula versus the expanded structural formula. And we're going to do some revision too after we get through this learning material. In the second half of today's class, we'll get introduced to a revision game where we're going to recap how to name all 7 types. So amines is our first one today. So amines have what is called an amino functional group, which is a nitrogen with 2 hydrogens bonded to it, NH2. And amines have priority when it comes to naming and numbering along the carbon chain over alkanes, alkenes, alkynes, and haloalkanes. So they have priority. If there's an amine in the carbon chain, we want to start numbering that chain from the end closest to the amine. We don't care if there's a halogen on the chain on the other end. We start numbering the chain from the end closest to the amine. And it's a bit of a choose your own adventure. There's 2 valid ways to name amines, and you choose which one you like. So you can see with the 2 examples I have on the board there, I have 2 names provided under each structure. The one in italics is an alternative, where the suffix is changed from like propane to propanamine, or you could use the amine name as a prefix. You can call it 2-aminopropane. So both of these names are valid, and they both are names for the same structure. So 2-aminopropane versus propan-2-amine. They mean the same thing. So there's an amine group on the second carbon. And you can see that alphabetically, our alphabetical naming system still applies. If you were to use the prefix amino, A comes before the letter M, so we say 3-amino-2-methylpentane, right? Even though the amine group is further along the chain on the 3rd carbon, and we have a methyl group on the 2nd carbon, we don't number or name them by how early along the chain they appear. We name them alphabetically, so 3-amino-2-methylpentane. Or you could call it 2-methylpentan-3-amine. Do you have any opinions which ones you prefer?
No, they both seem valid.
You could use either or, but
I like the pre-amino
yeah, it just sticks with the alphabetical system we know, right? You know. Both are valid though. NCEA will accept both on the exams. You might be wondering what this is on the right. This is just a screenshot of part of the priority list, which you can access via the link I've provided on the slides here. So the higher up a functional group is, the higher its priority is. So you can see alcohols up here, and then amines down here. So that means alcohols have priority over amines. So if there was an OH group on a molecule and an NH2 group, the OH group would have priority. We would want to number the carbon chain from the end closest to the OH group, not the NH2 group. and that's what I've specified here. Amines have priority over some functional groups, but not alcohols and carboxylic acids. And you can see alkenes are down here. So if you open up the link and view the whole list, you'll get a better idea of where all these functional groups sit in relation to one another in terms of priority. Cool. So let's do 2 examples of the class as we did last week. I'm just going to put up 2 molecules and ask you guys to come up with the names. So have a think for a minute about both of them. Maybe scribble down a name, and then we'll take it up. These are both amines. They have other little things about it. These are challenging, probably much more challenging than what you'd see on a level 2 exam, but I want to test our ability to name. Hopefully I didn't mess up the names myself when I reveal the answers. I sometimes do. Have we got a proposal for the first structure? What should we name it? Jake wants to give it a go.
I think 1-amino 2,3-dibromo. Yeah.
1-amino 2,3-dibromopentane.
Yeah.
Any other proposals? Are we for or against that name?
4.
4. Sweet. We got confirmation. Seconded. Cool. That's the name I gave it. Or you could call it 2,3-dibromopentane 1-amine. So that's another name. Second structure is a bit trickier. I've deliberately drawn it kind of weird. What do we think? Have we got a proposal for this one? Looks like Wilma wants to say something. It's working frantically. You got one? Wilma, go for it.
3-amino 5-ethyl octane.
3-amino 5-ethyl octane. Is anyone else going to second that? Alex is nodding. Abigail, sweet. 3-amino 5-ethyl octane. There you go. Or 5-ethyl octane 3-amine. Sweet, we're pros. Pretty easy. And those were really hard. You won't see molecules that long with that many different constituents on it, usually on an exam. We'll look at exam questions eventually, and you'll be surprised by how small and simple the organic molecules are that they expect you to name. So let's move on to carboxylic acids. We're just zooming right along, and then we'll get into a revision, putting all 7 of these functional groups together, and testing our naming skills. So carboxylic acids, guess what? They're acids. They're weak acids, though. So what makes something an acid? Its ability to do what? Yeah, protons, which are H+ ions, right? Because a hydrogen ion is a proton surrounded by an electron, and when it's ionized, it loses that electron. So a hydrogen ion is literally just a proton. And that acidic hydrogen is the H on the end there. So carboxylic acids contain what's called a carboxyl group. So a C double bonded to an O with an OH group next to it. That's a combination of what we call a carbonyl group and a hydroxyl group. So here, this would be called not propane, but propanoic acid. It's a carboxylic acid. The suffix is oic acid. So propanoic acid. You've probably heard of ethanoic acid, which is the molecule of vinegar. And here I've got 3-methylbutanoic acid. It's 3-methylbutanoic acid because carboxylic acids have the highest priority out of all 7 functional groups we've learned. So that carboxylic acid functional group is always at the end of a carbon chain, always at the end. And so we don't even need to number it. We don't need to say it's on carbon 1. So this isn't propan-1-oic acid. It's just propanoic acid because it has to be on the first carbon. So we don't need to number it. But every other functional group is numbered in relation to that first carbon. And the first carbon is here, so the methyl group is on the third one along the chain from right to left. And when we write the condensed structural formula, I have, for example, here's ethanoic acid's condensed structural formula. See how I have not condensed the 2 O's into CO2H? We write it as COOH. So we separate the O's because they're bonded differently in the molecule. That's pretty easy. It's on the first carbon, so that tells you right away what the first carbon has to be. You don't need to work it out yourselves. And the suffix is the only thing that changes. So let's go over 2 examples, and you'll propose the name. Cool. Here are the examples. So the example on the left has a couple chlorines. Don't mistake those chlorines as carbons. What do we think? There we go.
I got 2,3-dichloro, 2-iodopropanoic acid.
I think that sounds good to me. Yep, 2,3-dichloro, 2-iodopropanoic acid. It's in alphabetical order for those functional groups. Remember, the D in di does not have any influence on alphabetical order. We're looking at the C in chloro coming before I in iodo. And keep in mind when you're writing out the names, and we need to do more practice where you show me your ability to write names, you should have dashes all the time between numbers and words. And iodopropanoic acid is a compound word. There's no space between iodo and propanoic. So just emphasizing those rules again. Okay, but there is a space between propanoic and acid. Cool. What about the second compound? What should we name that? Lulu. Figuring it out? Alex, what do you think?
2-amino-butane-1-oleic acid.
Close? The one thing is we don't need to number the location of the carboxylic acid group because it's always on carbon number 1. So I would call it 2-amino-butanoic acid. Shorter, simpler. So in this case, we have to name the amino group as amino. We can't change the suffix to amine because carboxylic acid has the priority. It is the suffix we got to use. It has to be butanoic acid. It can't be butanoic amine. That doesn't make sense. So we have to name the amino group as 2-amino as a prefix. Cool. So those are our examples. Now, here are the rules for our revision game. I gave you those cards last week to cut out by today. Thanks for the people who've got it ready today. That really helps. So here are the rules of organic chemistry, you know. So you're going to get into groups of about 3 or 4. You're going to shuffle the cards and deal 7 to each player. That will be your hand. So you can look at the 7 cards in your hand. And you're going to place the remaining pile in the center between you all and flip up the top card on that pile so you can all see that molecule. Now each player, clockwise, will take a turn playing a card from their hand of 7 on top of that up-facing card. Now that card you can play has to be one that is either the same type as the card face up. So if it's an alcohol that's face up, you can play an alcohol from your hand. Or if the card in the middle has 2 carbons in its structure, you can play a card from your hand that has 2 carbons in it as well. It doesn't necessarily have to be the same functional group. Yeah. So if you have ethanol, ethanol has 2 carbons, right? Eth meaning 2. And if you have ethanoic acid in your hand, you can play that. Where to move? Focusing. So even though they're different functional groups, they have the same number of carbons, so you can play that too. So you have those 2 options, same homologous series or same functional group, or same number of carbons. Now, if you're unable to play a card simply because you don't have a card that's the same functional group or has the same number of carbons, you must pick up a card and pass your turn. So if you pick up a card and it matches, you got to wait till next turn comes around to you to play that card. And as each card is played, this is the testing, this is the learning. You don't just play it and move on. You have to name it as you play it. So think about what is the name of the card I am about to play before it gets to your turn. If you get it wrong, you must pick up 1 card, and the rules actually state, normally it's 3, I'm being generous. As we get used to this game and as we become better at nomenclature, the penalty will increase to 3 cards. Not today, another time when we do this. And the winner is the first player to get rid of all their cards. Cool? So you play 1 card per turn and move clockwise. So are the rules clear? Cool. So I'll get into a group of 3 or 4 with somebody who has a deck of cards. Give it a go.
Should we want to go? I'm so glad of it's so cool. Should we come around there? Alright,
No, it's fine. I haven't even played the game and I already hate it.
Yeah, because it's just like
Right.